Everyone talks about artificial intelligence, but almost nobody talks about the one thing AI cannot exist without: electricity. Every new AI model, every data center, every chip, every single answer generated by a chatbot. All of it begins with one simple question: where will the electricity come from? The world's next economic superpower may not be the country with the smartest AI. It may simply be the country with the most power. Let's start with why AI turned into an electricity monster in the first place. Most people picture AI as something abstract: software, code, something that lives entirely inside a screen. In reality, every single AI response you've ever received came from a physical process: electricity turning into heat inside a machine somewhere on Earth. When you type a question into an AI chatbot, that request doesn't stay on your phone. It gets sent to a data center, sometimes thousands of miles away. Inside that data center, specialized chips called GPUs do the actual thinking, processing your request, running billions of calculations in a fraction of a second. These chips need memory fast enough to keep up with them. That memory is called HBM, high bandwidth memory, and it draws serious power just moving data back and forth constantly. All of this generates enormous heat, which means the servers need constant cooling, and cooling itself takes even more electricity. Some of the newest data centers now use liquid cooling systems instead of ordinary fans, since air alone can no longer remove heat fast enough from the densest server racks. Even those liquid cooling systems, ironically, still need a steady supply of electricity to keep pumps and chillers running around the clock. So every single AI answer is really a small, invisible transaction. Electricity in, heat out, answer delivered. Multiply that by billions of queries a day across dozens of competing AI companies, and you start to understand the real scale of the problem. One AI query can use roughly 10 times more electricity than a simple web search. And training a single large AI model from scratch can consume as much power as tens of thousands of homes use in an entire year. To put that in perspective, imagine an entire mid-sized American town. Every house, every appliance, every streetlight running for 12 straight months. That's roughly the electricity bill for training just one modern frontier AI model before it's even released to a single user. This is why inference cost, the cost of actually running AI once it's built, keeps climbing. Not because the software got worse, but because electricity, the raw fuel behind all of it, keeps getting more expensive and harder to secure. And that single fact is now quietly reshaping electricity markets around the entire world. The United States, China, Saudi Arabia, the UAE, and France are all suddenly racing toward the same goal: more power, as fast as possible. In the United States, utility companies are being asked to supply amounts of electricity they've never had to plan for before. Some data centers now request as much power as an entire mid-sized city, and they need it running 24 hours a day, without interruption. A handful of individual data center campuses currently under construction in the US are each expected to draw more electricity than an entire American state used just 20 years ago. Utility planners who normally forecast demand growth in small, predictable percentages each year are now fielding single requests that could double a region's electricity needs almost overnight. China has been building electricity generation capacity of every kind at a pace no other country can currently match. Coal, solar, nuclear, all expanding simultaneously, specifically to support its own AI ambitions. China's approach benefits from a level of centralized planning most Western democracies simply don't have. When Beijing decides a region needs new power capacity, permitting and construction can move at a speed that would take years longer almost anywhere else in the world. Saudi Arabia and the UAE are pouring billions into new data center infrastructure, betting that cheap, abundant energy can turn them into major AI hubs, not just oil exporters. Both countries are leveraging something they already have in abundance: extremely cheap energy production, and using it as a foundation to attract international AI companies looking for guaranteed low-cost power at massive scale. France, meanwhile, is leaning on something it already has plenty of: nuclear power, built decades ago, now suddenly looking like a strategic advantage nobody predicted it would need again. France generates a larger share of its electricity from nuclear power than almost any other country on Earth, a decision made decades ago for entirely different reasons: energy independence after the oil shocks of the 1970s. That older infrastructure is now positioning France as one of the more attractive locations in Europe for new AI-related data center investment. Natural gas plants are being proposed specifically to serve single data center campuses. Renewable energy projects are being fast-tracked, not for climate reasons alone, but because AI companies simply need more electricity from anywhere as quickly as possible. Electrical grids, built decades ago for a completely different world, are now being asked to absorb demand nobody designed them for. Which raises a bigger question. What does this actually mean for the next century of global power? In the 20th century, oil defined geopolitics. Countries with oil had leverage. Countries without it depended on those who did. Wars were fought over it. Entire foreign policies were built around securing access to it. Nations without domestic oil production spent decades building relationships, and sometimes militaries specifically to guarantee a steady supply. In the early 21st century, that shifted towards semiconductors. Whoever controlled advanced chip manufacturing controlled a critical piece of the modern economy. A handful of companies, concentrated in just a few countries, suddenly held leverage over nearly every other industry on Earth, since almost everything modern eventually needs a chip somewhere inside it. Now, a new resource is quietly climbing to the top of that same hierarchy: electricity. Because without enough of it, none of the chips, none of the data centers, none of the AI models actually function at all. Oil can be shipped across oceans. Chips can be shipped across oceans too. Electricity generally cannot. It has to be generated close to where it's used, which means the countries able to produce enormous amounts of reliable power locally may end up holding the real leverage in this new era. That's a genuinely different kind of advantage than oil or chips ever provided. You can't simply import electricity the way you import a barrel of crude or a shipping container of processors. You largely have to make it yourself, close to where you need it. And here's the uncomfortable part. That shortage has already started. Across the United States, dozens of proposed data center projects have been delayed or outright rejected, specifically because local power grids simply can't support them yet. Transmission lines, the physical infrastructure that moves electricity from power plants to where it's actually needed, are badly outdated in large parts of the country. Building new transmission capacity typically takes 5 to 10 years, from planning to completion. AI data center demand arrived in a fraction of that time. New power plant construction is facing similar delays, stuck in permitting processes designed for a much slower era of electricity demand growth. Some proposed natural gas plants meant specifically to serve data centers have already faced multi-year delays, simply waiting on environmental review and grid connection approval. Meanwhile, utility companies are dramatically increasing their own capital spending, trying to catch up. Some utilities have announced spending plans significantly larger than anything in their previous history, specifically to build out capacity for data centers. Several major American utility companies have revised their multi-year infrastructure budgets upward by tens of billions of dollars in just the past 2 years alone, almost entirely driven by data center demand that didn't exist at this scale before. And this is where something interesting happens in the stock market. Everyone assumes the biggest winners of the AI boom are chip companies. Nvidia gets mentioned constantly, and it deserves the attention. But it's not the only company profiting from this shift. Companies that build the actual electrical infrastructure underneath AI, transformers, industrial power equipment, grid technology, have quietly become just as critical to this entire boom. Companies like GE Vernova, which builds power generation and grid equipment, have seen enormous demand increases tied directly to data center growth. Order backlogs for large power transformers, a genuinely unglamorous piece of equipment most people have never heard of, have stretched out years in some cases, simply because demand has outpaced global manufacturing capacity. Siemens Energy, a major player in electrical infrastructure and turbines, has become deeply involved in powering new data center projects across multiple countries. Schneider Electric, which specializes in power management and industrial electrical systems, has become essential to how modern data centers actually distribute and manage their electricity internally. Eaton, another major player in electrical components and power distribution, has seen surging demand specifically tied to data center construction. And ABB, a global leader in industrial automation and power technology, has become deeply embedded in how new data centers get built and powered from the ground up. None of these companies make headlines the way AI chipmakers do. But without them, none of the physical infrastructure powering AI actually gets built at all. So who actually makes money in this new landscape? Not just chip companies, power companies, transformer manufacturers, cable producers, cooling system builders, nuclear technology developers, natural gas infrastructure companies, industrial electrical equipment makers. The AI boom underneath the surface is really a massive electrical infrastructure boom. And the winners include an entire category of companies most casual observers have never even heard of. Which brings us to one of the strangest shifts happening right now. Why is America suddenly talking about nuclear power again? For decades, nuclear energy was treated as a dying industry in the United States. Too expensive, too politically difficult, too slow to build compared to natural gas or renewables. Public sentiment toward nuclear power had also cooled significantly after past accidents elsewhere in the world, making new plant approvals politically difficult for decades regardless of the underlying economics. That's changed dramatically in just the past 2 years. Small modular reactors, often called SMRs, are being developed specifically with data centers in mind. Smaller, faster to build, and designed to be sited directly next to the facilities that need constant, reliable power. Unlike traditional nuclear plants, which can take over a decade to build and cost tens of billions of dollars, these smaller reactors are designed to be manufactured more like standardized industrial products, potentially cutting both cost and construction time significantly. Companies like Constellation Energy have signed deals to restart previously shut down nuclear plants, specifically to guarantee electricity supply for tech companies. One previously decommissioned reactor, shut down for economic reasons years earlier, is now being brought back online specifically under a long-term supply agreement with a major technology company, something that would have seemed almost unthinkable just a few years ago. TerraPower, a nuclear technology company, has been developing next-generation reactor designs aimed partly at exactly this kind of dedicated industrial demand. Oklo, a smaller nuclear startup, is specifically targeting data centers and AI infrastructure as its primary customer base, betting that this demand alone can justify building an entirely new nuclear supply chain. And the companies driving this demand aren't utility companies at all. They are Google, Amazon, and Microsoft. Big tech companies that, until very recently, had almost nothing to do with the nuclear industry. Now, some of them are signing direct agreements to fund reactor restarts and new nuclear development, specifically to guarantee their own future electricity supply. Think about what that actually represents. An entire energy industry, considered essentially dead just a few years ago, being revived not through government policy, but because private tech companies are willing to pay whatever it costs for guaranteed, always-on power. Which leads to the next uncomfortable question. Is electricity itself becoming a new kind of geopolitical weapon? Electricity exports, historically, were relatively rare, since power generally needs to be used close to where it's produced. But that's beginning to shift. Cross-border transmission projects are becoming strategically important, allowing countries with surplus power generation to sell excess electricity to neighbors who need it. Europe has been building interconnected grids for decades, allowing countries to share power across borders during shortages or surpluses. That interconnected system is now becoming strategically valuable in an entirely new way, as AI-driven demand grows unevenly across different countries. A country with surplus renewable or nuclear generation capacity suddenly has something genuinely valuable to trade, not oil, not chips, but the raw electricity itself, sold directly across a border to a neighbor scrambling to power new data centers. China's massive, centrally coordinated energy build-out gives it a structural advantage here. The ability to rapidly deploy new generation capacity, of nearly any type, faster than most democratic countries can navigate their own permitting and approval processes. The United States, despite having some of the most advanced AI companies on Earth, faces a genuinely awkward mismatch. world-leading AI software built on top of an electrical grid that, in many regions, wasn't designed for anything close to this level of demand. Which countries end up with the advantage here isn't fully settled yet. But the countries that can generate abundant, reliable electricity quickly may end up holding more leverage in the AI era than the countries that simply build the smartest models. So where does all of this actually leave us? The AI race isn't really about artificial intelligence at all, at least not primarily. It's about something much older: energy. History tends to remember the companies that built the internet, the companies that built the smartphone, the companies that built the first genuinely useful AI models. But the next decade may end up belonging to a very different, much less glamorous group of companies, the ones that simply keep the lights on. The future of AI may ultimately depend less on who builds the smartest model, and more on a far more basic question: who can generate the next kilowatt hour reliably and fast enough to keep up?